Hello, everyone. Let's talk about section 8.3. This is about polar graphs. Now, the idea with polar graphs is that it's a circular grid rather than a square grid. So you have here an example of a graph of a polar coordinate here. And so the way polar coordinates are written is r comma theta. So instead of x comma y that they use for good old-fashioned rectangular coordinates, a polar coordinate is always r comma theta. R refers to the length of the radius. So you may recall we were talking always about the unit circle, and we would have the radius and it would start on the positive x-axis. We would spin counterclockwise. And so here, this is the location of the point 2 comma pi over 4. So 2 is referring to the length of the radius from the center of the circle, the pole, if you will. This is called the pole, kind of like the North Pole or something. And then the pi over 4 refers to the angle that you would have to spin from the positive x-axis, how far you would have to spin counterclockwise to reach that location. So this is kind of the gist, the general form of a polar coordinate, what it means and how it is found. So here we have plotting a point on a polar grid. And they say plot the point 3 pi over 2 on the polar grid. As you can see, there's a very lovely polar grid that is provided for us. And they were very nice and included both the radian and degree measures of the angles. So whichever way you want to measure it, they're both there. So really what we'd probably want to do first if we were to graph this is we'd want to find where pi over 2 is, which you will notice is right there. Pi over 2 is radian speak for a 90-degree angle. And then if the radius, where's my little pen thing? If the radius is 3, that just means that we're going to spin 90 degrees from the positive x-axis where that typically is. And then we're going to count 3. We're going to go 1, 2, 3. And there you go. The third circle out, that is the location of 3 pi over 2. So when graphing polar coordinates, the r tells you the length of the radius. It's how far you're going to move from the pole. But before you do that, what you probably want to do is look at the angle theta that is provided to you. And then based on the angle, that'll sort of tell you what direction you're headed. And then once you know the direction you're heading, you can then move however far you are supposed to based off of the radius. Here's another one. They say plot the point negative pi over 6 on the polar grid. Now we know what pi over 6 is. That's going to be this angle right there. There's pi over 6. And like typically you'd go off that way. If it's negative, that means what we're actually going to do is we're actually going to go in the opposite direction here. We're going to go 2 sort of in the other direction that's 180 degrees across. So the point negative 2 pi over 6, let's try that again. So the point negative 2 pi over 6 is going to be right there. That's negative 2 pi over 6. And so essentially what happens is that if you were going positive 2, you go this way. but since it's negative, we're going to go 180 degrees and basically go backwards. So because this is negative, we're going to go backwards. And so it's an angle 180 degrees, also known as pi, since we're in radians, 180 degree turn from the original. So that would be how you would graph something with a negative radius. That's what a negative radius would mean. Now, one thing that is handy to do is being able to convert between rectangular coordinates and polar coordinates, because you can describe the same locations on the same graph. It's just a question of what's sort of your frame of reference. Are you thinking of moving as the crow flies so that you've got like a bunch of concentric circles, or are you more like moving along streets along like a fixed grid where you have to follow the rectangular edges and you can't just go straight like as the crow flies? So the way that you could convert between the two, here you have a diagram showing just a random point, and we have it both drawn with the XY values as well as the R theta values. And this is sort of what ties it into trigonometry, which we've been spending an awful lot of time lately talking about. So we know, based on the definition of the different trig functions, if this is your angle theta right here, the cosine is going to be the opposite, or I'm sorry, the sine is going to be the opposite over the hypotenuse, also known as y over r, which is what they're saying down here. And if you just do a little algebra and multiply both sides by r, you end up with this very lovely handy formula right here. Y is equal to r sine theta. And then similarly, the adjacent over the hypotenuse is the definition of cosine based on good old-fashioned SOHCAHTOA from back in the day. So if your goal is to find the x coordinate, that would be r times the cosine of theta. So that's how you could take a polar coordinate where you knew the r and the theta and transform it into something you're probably more accustomed to dealing with, which would be the XY coordinates. In addition, if you have the X and Y coordinates, you could do a little bit of algebra and kind of go the other direction and make them polar coordinates if you were so inclined. So they say, write the polar coordinates 3 pi over 2 as rectangular coordinates. So r is equal to the number 3, that's the first value. Theta is equal to pi over 2, that is the second value. So if we want to know x, and this goes back to stuff we've emphasized before, remember the x direction always goes with the cosine. So the cosine is going to correspond with x here. So x is going to be r cosine theta. So in this case, we're going to do 3 times the cosine of pi over 2. And fun fact, the cosine of pi over 2 happens to be the number 0. So this is 3 times 0, which means we get 0. Meanwhile, y is equal to r sine theta. So what that would mean is that y is equal to 3 times the sine of pi over 2. The sine of pi over 2 happens to equal 1, because fun fact, if you have a unit circle here, pi over 2 is right here. And this would be the 0.01. So the 0 is the x value for cosine, the y value 1 is for sine. So this is 3 times 1, meaning you get y equals 3. And you put it together, you get your answer, which is 0, 3. So 0, 3 is that point right there. And lo and behold, that would be equivalent to if you did a turn of pi over 2 and then moved 1, 2, 3 radii out from the pole, from the center point. So that would be how you would turn that one as how you would turn it into a rectangular coordinate. Here we're doing a similar sort of thing. So again, we've got this formula here and this formula here that we're going to use to do this problem. This problem, we have r is equal to -2, and the value of theta is 0. You can have an angle of 0. That means you're on the positive x-axis. You haven't spun or turned or gone anywhere. So for x, we're going to do -2 cosine 0. Fun fact, cosine 0 is the number 1. So that just means the x value is going to be -2. Meanwhile, y is equal to -2 times the sine of 0. The sine of 0 is 0, so this is -2 times 0, meaning y is equal to 0. And you put them both together and you get the point -2, 0. Fun fact, that's actually exactly the same as the polar coordinate. So often that doesn't happen, but this is kind of a quirky one where that is what happens. So like -2, 0 would be over here. And so if you have a 0-degree angle where you don't turn, and then if you're going to go backwards, you're going to go like that way, 2 spots. And there you have it. That will be the location of that polar coordinate, which in this case, kind of interestingly, is identical to the rectangular coordinate. All right, so converting from rectangular to polar coordinates, that is typically a little more involved, but there is a way to do it. That's kind of what we're going to focus on next. So based on good old-fashioned Pythagorean theorem, the radius squared is equal to x squared times y squared. So we could go between the two just by the fact that r squared is x squared plus y squared. And then fun fact, if you want the value of theta, probably the easiest, because if we want to do things only in terms of x and y, also known as the opposite and the adjacent, well, the trig function, if you go back to good old-fashioned SOHCAHTOA, would be tangent. And if you do the tangent of the angle, that's the opposite over the adjacent, also known as y over x. So these are the formulas that we could use to then go from a polar coordinate and turn it into a rectangular coordinate. Or I may have said that backwards. Go from a rectangular coordinate and turn it into a polar coordinate, because we know x and y in this situation, and we're turning it into something that is polar. Okay, so they say writing a Cartesian equation in polar forms. They say write the Cartesian equation x squared plus y squared equals 9 in polar form. All right, what on earth does that mean? Well, we were just talking a moment ago about how x squared plus y squared equals r squared. And so in this case, because x squared plus y squared equals 9, for substituting all of this equals r squared and all of that equals 9, what that means is that r squared is equal to 9. And I can even do you one better, because if I take the square root on both sides, that tells me that r is going to equal 3. So the equation in polar form is going to look like this. So basically what you're going to do is you're going to graph all points with a radius of 3. So if we find where we have a radius of 3, you've got 1, 2, 3. So there's a radius of 3. And if the equation is r equals 3, what that means is that we're basically going to plot every location where we will end up with a radius of 3, which is basically going to give us this circle right here. And depending on how well you remember algebra, this is actually the equation of a circle. With radius 3 and the center at 0, 0. You might have a vague memory of talking about that in an algebra class once upon a time, maybe, possibly, but that would be that's an equation that would give you a circle. And in polar form, it looks a lot simpler. It's just r equals 3, which means plot every point where the radius is 3. And in rectangular terms, that's the equation of a circle where the center is located at 0, 0. And so that's two different ways of describing the same thing. Here they say, rewrite the Cartesian equation as x squared plus y squared equals 6y. Rewrite that as a polar equation. So what that means, we know x squared plus y squared equals r squared. That's one thing that we know. And then the other thing that we know that y equals r. Let's see, y is sine, y is equal to r sine theta. So basically what this means is that r squared, that's what x squared plus y squared equals, that's r squared. And then we're going to replace the y with r sine theta. So that's going to equal 6 times the y, which is r sine theta. You can basically like divide by r on both sides if you assume that r is or r not equal to 0. This is basically saying that r is equal to 6 sine of theta, which would be the equivalent version of that equation. So what this is going to look like is it's going to, sine means you go in the y direction. And then this is basically how far you go. So what this equation would happen to look like is you would start at the pole, you would go up 6, 1, 2, 3, 4, 5, 6. You have a point right there. And then basically what you would have, the center is like going to be right there, halfway, and you would have a circle that kind of goes like that. It's a little lopsided, but you end up with a circle going from 0 to 6, and you can tell that it's oriented going up because it's going in the y direction. And you're going up because the value of 6 is positive If it were negative, that would mean you would go down. But that is what the graph of that would end up looking like. Here's another one. They say rewrite the Cartesian equation as a polar equation. This is going to get super messy real quick here. So remember that y equals r sine theta, and then x is equivalent to r cosine theta. So what this is going to mean is that r sine theta is equivalent to 3 cosine, and let's see here, 3 cosine theta plus 2. And so, and let's see here, we're going to, let's see, I left off the r, that's what the problem is. Okay, so you've got 3 times r cosine theta plus 2. Now, our goal is to solve for r, because when you have polar equations, it's always going to be r equals something in terms of theta. So what you would need to do if you're going to solve for r is all the parts of the equation with r need to be together on the same side of the equation. So this is r sine theta minus 3r cosine theta. That all equals 2. Then what you can do is you can factor out r from both of those, which leaves you with sine theta minus 3 cosine theta. And that all equals 2. So then if you divide by this, you will solve for r. And as I kind of mentioned at the beginning, this is going to be kind of icky looking, but so you've got 3 sine theta minus 3 cosine theta. That is what the equation would look like. The polar equation would look like, where it's r equals something. Typically with a rectangular equation, you always have y is equal to something because it's like y equals mx plus b. When it's in polar form, what you are interested in is having it as r equaling something in terms of theta. And the graph in rectangular form is just going to be a nice, neat line because y equals 3x plus 2 is just an equation of a line. Doing that, graphing it in polar form is going to be a lot more trouble than it's worth, which is partly why we're not asked to actually graph it. But that is how you could take something like the equation of a line, and if you wanted to express it in polar form. So there you go. That's your equation. Okay, so that is the end of this section. So we will stop the recording there. And